Hey y'all. Today's objective is probability and geometry. And the reason I've titled it probability and geometry is because it's all about finding the probability of hitting targets or making baskets where there are shapes involved. And here are the shapes that we will be using. So copy these shapes down and get the area formulas for them. And we'll be using them in our examples. The square, rectangle, triangle, and circle. So copy those down. And example number 1 says find the probability of throwing a dart and hitting the circle. Throwing a dart. So we have a square with a circle inside. And the question says hitting the circle. So we are looking for the area, the circle right here, not the four corners. So I have over here the target area is the circle. That's what we want to hit out of the total area, which would be the square. So you're going to have a target area and you're going to have a total area. Hang on just one second. Sorry. I got a text. If it keeps beeping, I won't work. Okay, so we have, right, a target area and a total area. So that's what you're going to hear me saying, a target area and a total area. So our target area is the circle, the total area is the square. So we have to find the area. Now how about here? The circle would be pi r squared because the radius is 5. And when you type that in, 3.14 times 5 squared, I got 78.5. And then the total area of the square, since this is 5, that means this would be 5, and total would be 10. So it would be 10 squared, which is 100. And then because it's already out of 100 means percent, so our answer would be 78.5%. So we have a 78.5% chance of throwing a dart and hitting the circle instead of the four corners. So that's how you would work problems like these. The target area out of the total area. We'll do some more examples. Alright, example 2. Find the probability of hitting the shaded region. So we have two circles, an outer circle and an inner circle. Kind of looks like a tire. So what is the probability that you'd hit the purple shaded region? So over here we have our target area and our total area. The target area is just the purple. So it's the big circle and when you take out the small circle. So the big circle minus the small circle. We have to take the small circle out. The total area would just be the big circle. That's the total area. So this one has a couple of different steps. So let me show you what I've done. I found the big circle area to be pi times 8 squared, because if this is 4 and this is 4, total together would be 8, because 4 plus 4 is 8. So total would be 8. And I got 296. Let me check, make sure. 3.14 times 8 squared. Yep. Then I found the small circle, which would be pi times 4 squared, because from here is just 4. And I got 50.24. So I found the area of both circles. Now I just have to do a little subtraction. The big circle minus the small circle. So this is our target area. And we need our total area. The total area is the big circle. So that would be the 200.96. And we want a percent. So we set it up as a proportion. We want a percent. We set it up as a proportion. So now I can solve it. 100 times 150.72 divided by 200.96. And it comes out to be 75%. That is the probability of hitting the shaded region on the outside. The shaded region on the outside. So I did the big minus the small out of the total, and then I made it to a percent. All right, so example 3, what is the probability of not hitting the circle? The word not hitting the circle. So we want to hit basically the 4 corners, not the circle. So we have our target area. Our target area is the 4 corners. To find the 4 corners, you'd have to find the square, and then you'd have to take away the circle. So square minus the circle. The total area would again be the square. So we have our target area and our total area. So let's come over here and look. The square has sides of 16. So we would do 16 squared and we get 256. This would be our total area. The circle is pi r squared, so half of 16 is 8. So I'd have to use pi times 8 squared, and I got 296. So now I need to do the square minus the circle. So 256 minus 296. 256 minus 296, and I get 5504. That is my target. That is the 4 corners. It's a small amount because we're talking about the 4 corners. So this is my target. So 5504 over my total area, which is the square. And I know that is 256. I'm going to set it up to x over 100. So 55.04 times 100. Oops, divided by 256. And I get 21.5%. 21.5%. So I took out the circle and found the 4 corners, not the circle. Ah! Whoa. I don't know if y'all could see that. No. Example 4, a board with 3 equal size holes for beanbags is drawn. So we have a board with 3 equal size holes. And I guess, you know, you're throwing beanbags in them. What's the probability of making it into the hole? Or holes, I guess. So all 3 holes. Our target area are the 3 circles. 1, 2, 3. It's nice because all 3 circles are the same size. So we can find one circle and multiply it by 3. The total area is the rectangle, the big board. So we need our target over our total. The circles are pi times radius squared. Whoops, I made a mistake. So if the diameter is 1, the radius is 0.5. 0.5. And then this is wrong. And this is wrong. Sorry. So 3.14 times 0.5 squared, and it's 0.785. And you do that times 3, and we get 2.355. And again, I multiplied it by 3 because there are 3 circles. And I got the 0.5 because it's half of the diameter. The board is length times width, so 3 times 6, and we get 18. And now I need my target. My 3 circles were 2.355 over my total area, which is 18, and set it up as a proportion. So 2.355 times 100 divided by 18. Ooh, and I get about 13.1%. 13.1%. So that means I have a very small chance of getting the beanbags in the holes for this beanbag game. Okay, and that's it. So I know these can seem difficult. Tomorrow we're going to practice targets, cornhole, beanbags, all sorts of stuff, and we'll practice this tomorrow.